In this video I will show you how to use stud in AlphaCell. So first we will load some materials. So we will load a hair layer, a plasterboard layer and a rock wool layer. Then we can build some first partition without stud. So a plasterboard layer of 12.5mm thick, some hair, some glass wool and some hair, and again a second plasterboard layer. We can compute a first sound transmission loss for this double wall partition without stud. So I've put here some values for the thickness, but of course you can change it to whatever you want. So here is a sound transmission loss for our partition without stud. So we can see here the breathing frequency, and here this is probably the critical frequency. To be sure, I drop the plasterboard layer on the right panel, and we can see that the critical frequency is around 2500 Hz, and this is what we can see here. So breathing frequency here and the critical frequency for the two plasterboard layers of 12.5mm thick. So now we will create the stud system. So I will remove here those layers. I click on the first plasterboard layer and I add a layer just right after. For this layer I choose a stud model, and then I drag and drop my layers in this stud model. And you can see here that we have some graphical representation of our stud with black lines on the top and on the bottom of our layer, which is a complete layer composed by hair, glass wool and hair. Of course we can change the thickness of everything here on the stud system. I will keep a 20mm thick here to be able to compare with my first result. And then we have to choose between two connection types, which are line or point. So here is just a graphic representation of our line and point connection. So for line connection we have vertical studs like this, which are spaced with a distance which is LH, so the horizontal spacing between two vertical studs. We can also have this kind of line connection, so with vertical and horizontal studs, and so we have an horizontal spacing between two vertical studs and a vertical spacing between two horizontal studs, which is LV. For point connection we have of course LH and LV, so LV is not represented here but we have LV, and we have LP, which is the distance between two screws in our system. So first we will choose a line connection, so I have to enter the value of stiffness, so this comes from measurements. So this is the mass in kilogram per meter, and this is the stiffness in Newton per meter. So the mass, for example, is 1.6 kilogram per meter of our studs connections. We can have a damping for our stud, so LH, the distance between, as we can see, two vertical studs. So here we can have, for example, those 0.6 meter and 2.5 meter for LV, and then I can run a new simulation for the double wall partition with the stud connection, the line stud connection, and here it is in violet. So we can just add some comments. So this is a no stud simulation and this is the line stud simulation. I update it, okay, and I will just hide the no stud connection just to show you here the path of the sound path. So we can here see the airborne and the solid-borne path to build our sound transmission loss. And we can see that our transmission loss is the result of this airborne and structure-borne path. And we can also see the effect, of course, of the studs on the sound transmission loss. If I want to change for a point connection, I just have to enter a value for the screw spacings in the studs, and of course I have to adjust the value of the stiffness and the mass for the connections. And of course we can run a new computation for this second connection type, which is a point connection type, and the results appear here in brown. Of course we can add, if we want, some windowing information and computation, so following the Vigran modeling or the RASI one. Here I just made simulation without windowing. Of course, we can have information about the global indicators by clicking on the show indicators icon, and we have here the value for all three simulations. Thank you for watching.